All right, we're back. So the next scenario we're going to use for the next 3 questions. So we have the noise level in a restaurant is normally distributed. When it's normally distributed, that's our normal curve. Okay, the average, that's the same thing as the mean, is 30 decibels. So that goes right in the middle. And the standard deviation is 4. Technically, we could label this and use the empirical rule, that whole 68%, 95%, and 99.7%. But I'm not going to use that because we actually have a normal CDF calculation that works for everything. It works for above, below, and in between. And then when we have a question like 44, when they say the noise is below, so that's good. So the noise is below because that's going to be inverse norm. Because they're asking what the noise level is below 99% of the time. So I know that I want the probability that x is less than something is 0.99. And that's when we use something called inverse norm. So remember, to get to inverse norm, it's the same menu as normal CDF. We're going to do second distribution, but instead of hitting number 2, we hit number 3. Once again, my calculator asks me, what's the area, what's the mean, what's the standard deviation? But your calculator may not. So you have to remember that if you're going to plug it into inverse norm, first of all, that only works for at or below, essentially, okay, which is what we have. The area that's shaded is 0.99. We'll talk about how we have to change that if it's not below. So that's the area. The mean is 30, that's the mean, and the standard deviation is 4. So typing that in, I get asked, so it's just going to be 0.9934, but you may have to type it in with commas. So inverse norm, 0.99, comma 30, comma 4. And that's how I get 39.305, which is letter A. Okay, let's see what we have on the next page. Now they want to know what is the probability that the noise level is between 26 and 31. So since I'm actually trying to find the probability, I'm going to go ahead and just use my normal CDF calculation because this is the normal curve, and I want to actually find the area. So to find the area, you use normal CDF, aka the probability. Remember, normal CDF is lower bound. So in this case, my lower bound is 26, comma upper bound, which is 31, comma the mean, which is 30, comma the standard deviation, which is 4. So this is lower, this is upper, this is mean, and this is standard deviation. And you get there the same way by doing second vars, normal CDF. My lower is 26, comma upper is 31, comma mean is 30, comma standard deviation, which is 4, and I get 0.440. Okay, the next one, 70% of the time the noise is above what level? So this is an issue because they're saying above what level? They're giving me a percentage, which remember is a probability, which means I'm going to use inverse norm, but inverse norm does not work for below. So you have to think about this logically. If 70% of the time it's above, below equals 30% of the time. So using my inverse norm, my area I'm going to plug in is not 0.7, it's going to be 0.3. Then comma the mean, comma the standard deviation. So you do have to be careful. Inverse norm is restrictive, just kind of like binom CDF is restrictive. They only handle things below. But if I remember right, that's really the only thing you have to worry about. So typing that in, I get 27.902. So letter D. Okay, and then the last one, oh no, that was actually my 3 questions. So this is a new question. All right, so number 47, a sample of 320 beetles is taken and it is found that 300 have a genetic abnormality. What's the sample proportion? Okay, sample proportion, remember, is p hat. And the way we calculate p hat is x over n. So you take how many it actually happened to, so number of desired events, I guess, which is 300, divided by our total sample size, which is 320. And that's how I get our sample proportion of 0.938. 48. It is believed that 80% of all residents of the villages of Willow Bay have a broken fence. What is the minimum sample size that would need to be taken in order to make sure that the sampling distribution of p hat is approximately normal? Remember, for proportions, this is not means. P hat is sample proportion. So for proportions to be approximately normal, you have to show that n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So let's see, they're giving us possible sample size, and they gave us the proportion, so 80% is our proportion, so that's 0.8. So I'm just going to go ahead and just plug in each of these. It's multiple choice like your final will be, and see which one works for both. So 13 times 0.8 is greater than or equal to 10, and 13 times 1 minus 0.8, thinking ahead there, is not greater than or equal to 10. So that would not be approximately normal. Okay, the next one, 0.8 times 50, so sample size times 0.8 is greater than or equal to 10, and sample size times 1 minus 0.8 is technically greater than or equal to 10, right? 10 is greater than or equal to 10. So B is working. Let's see, we could try 54 and 60, but they said the minimum sample size. So I'm not going to try those because if 50 works, of course 54 and 60 are going to work, but they said minimum sample size, so you have to pick the smallest. Okay, we have a confidence interval is computed to be 0.2 plus or minus 0.12. What's the name for the value 0.2? Well, remember when you calculate a confidence interval by hand and not in your calculator, you add or subtract something called the margin of error. So that would be the 0.12. But this 0.2, depending what unit you're on, if you're talking about means or proportions, this would be your sample proportion or your sample mean. So p hat or x bar. So this is p hat or x bar for our purposes. And the general name for that is that it's our point estimate. So it's your point estimate plus or minus the margin of error. And number 50, which must be true of a sample in order for it to be appropriate to use a confidence interval to estimate the population proportion. This is kind of hinting towards checking your conditions. I'm going to go ahead and put that down. So this is thinking about conditions. Once again, you guys have to keep the conditions straight, whether we're talking about proportions or means. We are talking about proportions. So to see if it's approximately normal, we talked about that above, 48, it's n times p, and n times 1 minus p. Notice how they have that in letter B, but they say p hat instead of p. We talked about that in confidence intervals. The whole point of doing a confidence interval is to estimate the population proportion. So if you don't know the population proportion, to check that it's approximately normal, we would use the sample proportion. So that definitely has to be met. You definitely have to have a random sample. So C says both A and B. And then D says you can use a confidence interval for any sample. That's definitely not true. It's got to be letter C. Okay, then we have a 90% confidence interval for the difference in proportion of bottles that are defective by two different bottling plants is given. Does the interval show evidence that there is a difference? Okay, think back, guys. The number that means that there's a difference or not is 0. That's the number you care about. If 0 is within the interval, let's see where I'm at with time before I get into this. If 0 is within the interval, that means that you have to assume there's no difference, because when you did something minus something, you got 0, which means they're the same. If 0 is not within the interval, then there is a difference. So I'm going to get rid of A and D. So since it does contain since it does not contain 0, there's sufficient evidence to say that there is a difference. So just remember, guys, to say that there's a difference, 0 has to be out.